So, guys, today is another episode, and I'll talk about using render targets to draw something on the static mesh. I guess a couple of weeks ago I did a breakdown on Ryan Brock's technique, how he made a trick with render targets that can be applied over the skeletal mesh, and without any fancy stuff, there is no way how you can obtain the UV coordinate of the skeletal mesh to apply the targets on it. But today, as I said, we will talk about static mesh, and at the end of the year I'll tell you some tricks how you can use this technique to cheat on the skeletal mesh drawing. So let's get started. So first of all, think of this feature as the key parts of your project, because you don't need to have the ability to draw everything on everything, because it's a waste of resources, time, and just I guess stupid idea. So for this feature we need to have the proper collision channel, so only objects with this collision channel will be used for rendering render targets over the mesh. Also, we need to think of each element that can be used for drawing as a separate actor, because actor can have logic that you need into your gameplay. And the way I did this tutorial actually helps us to deal with some sort of complex meshes, if we just in case of the demo, I'll show you the static mesh that I did from the skeletal mesh of the character. You can see that we have one model, but each element here, you can see, is the separate mesh. So consider making your gameplay object like this one, so you will have only one component as a static mesh, but elements inside this model can be used as separate parts. For instance, if you have different UVs for each part, some sort of complex building with windows, with balconies, etc., that can be used as a single model, but with more detalization that's just solid colors. And if we use it as one character, one model, it only will cost us to, in this model, 7 draw calls. But if you can bake everything into one texture, it will be only 1 draw call. So my feature can support having one mesh with multiple materials, or multiple, the container. If one blueprint has several, let's say 10 static mesh components with different materials, this will also work. So let's continue. One moment, I need to tell you that you need to take care of the UV layout for each separate mesh you have inside your character. Your UV islands should be for each part, this one or this one, of the same scale. So if you try to draw with the brush on meshes with different UV scales, you'll see that the brush will apply it also with the different scales. The pros of this technique is that you don't really care about the number and the order of your material inside the mesh. So like if you have two different meshes, this one and other, that have different materials and different number of slots, you don't care about the order, because my system will work perfectly with this. Now let's open project settings, and under the physics tab we need to search for support UV from heat results that actually return the proper coordinates when we use it with line trace to like get the proper mesh that we need to draw render target over it. And one more option left is under the collision tab. It's the object channel that we will use for defining the object that we will use next with our rendering. Now let's go back to the logic. So the first part of our logic is to create the brush that we will use to draw on other meshes. We need to create the simple material. Blend mode should be set to additive because we need to apply each layer over the previous one. Shading mode set to be unlit, and don't forget to deselect apply fogging to make this material less heavy with the instructions. Here is the vector 4 attribute, just by default to show how our brush should look. I set the coordinates 0.5, 0.5. By default, as you know, UV coordinate is 0, 0 on the left upper corner and 1, 1 on right bottom corner. So 0.5, 0.5, it's actually the center of the coordinate, the center of the texture. This we will set through the blueprint, and we need to mask the RG channel. That's all we need, and subtract 0.5, so the center of our texture will be somewhere here. And from the texture coordinate we subtract this operation and support it with the within the UV coordinates to the texture. You can go with the texture sample and draw with any shape you like, or just use this one and multiply by the noise texture, but in case of the demo I'll just show you how it works with the simple round texture. Density set to 100 and radius to 0.02, so it's not covering the whole area, so it's the small brush. And we will use this material as the source that we will draw to the render target and apply it to the master material of each our meshes. So, for instance, if you open your master material, all you need to do is to make this logic. I use multiply and color just in case to show that, as you saw from the demo in the start of the video, that you can have any logic like after you apply the mask, and you can go with colorizing, or you can use this mask as the opacity to like make holes inside the object, etc, etc. And yeah, just this logic. So draw mask is the texture sample that is said to be attribute parameter, and the result of these computations will be calculated inside this sample. Then we use it as we want. So, and this one is masking, and we add it to the results of our base color, so it will be applied over our main texture. That's all that we need from our materials. Next thing is to create an object that we will use to draw over. So here you can see I have the blueprint actor. It is called draw target, and inside it I have the static mesh. Static mesh is the test mesh that I showed you earlier with its default materials. Next we need to set up the proper collision preset. It should be custom, and I got with the object type as I created earlier rt_test, and here I have the collision enabled but only query, and even with this setup it will stop me from intersecting with it if I try to walk to it. By default, all response channel set to be blocked. That's all we need from our test model at the moment. Then I'll explain these two simple methods, but it's a little bit next in the video. So now we need to open our character. In this sample I used first person character and make some changes like this one, this, and this function. And that's all. That's what we need from our character to start drawing with the render target. So first of all we need to create the material instance of our damage decal. It's a simple operation that I use on the event begin play. So once I had the reference of it, I can make changes to the attributes that's said to be adjustable or readable. Next, here I have also, for the sake of the demo, F key pressed and simple logic. So I use set timer by event and use loop with little time. So if I go with one hit, it will fire once, because on the release I have the clear and invalidate timer by handle. And if I continue pressing, it will draw maybe as the laser, like so. My event, all I need to do is to use the line trace for object. Make sure that you trace over the complex, because without it find collision UV won't work. You need to make array and support it with the proper channel to the object types. Here you can see I have the simple logic, so word location of camera, forward vector of camera, and this one is the distance, 1000 units from the points of where I am looking or where I'm standing. And here I check whether line trace is successful, so I am hitting the proper object. I use break hit results, and here I have the function that is called prepare data for actor, and I support it. As you can see, it's the function with two different inputs and one output. Actor, so the hit actor that we are colliding with, and face index. Face index will return the true mesh of the face of mesh that we are colliding with. And for the output is the simple texture render target 2D. So we will use it to draw over it. Next thing is to find the node, which is called find collision UV. Here we need to provide the proper UV channel, as I said earlier, that have the proper layout, and I make split on the UV coordinates and make linear color, so I provide it here inside the vector attribute. Make sure that you have this logic, so set vector attribute with the proper name. It's UV, so as I told you earlier, the attribute that will be offsetting the projection brush over the main material. And this is the result of the proper UV where the brush will be projected. And the last part is draw material to render target, also our brush, and the result of this function inside the texture render target. Now let's talk about this function. You can see I have some variables: last actor here, last face index, also have actors array and render target array. So what I do when I got collision with my proper actor, I store it and the face index of my collision as the last actor, so I can use it as the reference here. Then I check whether my actor contains, like here, just to have the clear and beautiful layout, whether this actor doesn't belong to my actor array. So if it's true, it means that I'm colliding with the new actor. Here I clear all the array of my render target, because you will see why I do this a little bit further in the demo. Then I add my actor to the actor array, so now it contains of one actor. Then from this actor I try to get the static mesh component, and because I don't need to select whether it's valid, to check whether it's valid, because as you know, here I've made it and this will always be here. And from this mesh I select get materials, and this will return the array of all materials that it has, all of them. In case you have the complex blueprint, like you don't have only one static mesh component here but several one, you just need to get components. You will receive the array of components and just make a loop inside the loop. That's it. Next, for each element I create dynamic material instance, so I can get the access to the draw mask, the texture that we need to provide our main material, so our brush will be drawn inside this texture attribute. And for each element I'll create the render target. Yep, the number of render targets is increasing due to number of unique material slots that we have. Because if we have one material slot with one texture that covers everything, this works fine. But if we have multiple, we need to create separate render target to properly adjust it to the texture. So this works automatically. Like if you have some troubles with performance, just make one render target, one texture that cover all your mesh, and use one material slot. And for each material instance dynamic, I use particular render target as the reference to the texture parameter, and don't forget to provide the proper name. Then I use set material for each static mesh component. In my case I have only one, so I go with this one, and each element here, it's the tricky part, like all materials here are counting with the 0 index that we have here, and each render target that is created will have the same ID. So, and if we are setting our material, our newly created material, with the set texture attribute of draw mask, they will also have the same index, so we don't get fucked up with the order of how the materials will be applied. And we store our render target here that we create for each element into the array. If we are colliding with one mesh, we only have one stack of render targets. But if we are colliding and we need to know or just store the progress of rendering over the previous target, we need to have another stack of render targets. And because this logic is like accumulating, this array will be increased in size. So it needs to store every render target for each actor. But we need to define the method how we can get the proper render target pack for each proper actor. And here comes the interface that we need to create. So we need to create the interface and provide two methods. One is for storing the proper rendered targets pack, and one is for retrieving this pack. So we will apply over each proper actor. Now, as you can see, I have the blueprint interface, which is called BPI draw target, and it has two methods: store render target data, and input is render target and its array, and get render target data. Input nothing, output array of the same render targets. Once you've done it, open your object, your actor, and in the class settings just add this interface. Now let's open our getter method, and you need to create the render target array variable and provide it here at the return node. And on the event graph we need to define the method event store render target, and render target that came from this interface should be stored inside our variable. So when we start drawing over the one actor, all render targets will be stored here. And when we are trying to draw over the other actor, this one will also fires. Each actor will store its particular pack of render target. And when we need to switch between actors, we will use this operation to retrieve the proper render target pack. Now back to our first-person character blueprint. So if we, like this one fires once, and once we have our actor inside our array, this logic will go next. If we have another actor, it will go in this particular logic, but not to store the unnecessary render target packs to our next actor. We need to clear this array, and that's how the new object will receive its proper array of render targets. So clearing the previous one for our old actor and create new one for our new actor. And if we are colliding with the same actor, we use get render target method last actor is the delegate to retrieve the proper render target pack, and we need to have return node here also. I'm sorry, I have forgotten to talk about this one. So once we are done with the loop operation here, all of our operations, our preparations made, on the complete we need to store the render target array that we create here inside our last actor, or our in the case of here it's our first actor, and we here also return the same logic as we have here. So last actor get component by class. Here we need to provide last phase index, because this one is one number, and this node get material from collision phase index will return the proper section index in case of the static mesh we are colliding with. So this one is one number, this one is separate one. They are not the same. This one is the index of the material slot we have here. So if we are colliding with our head, it will return element 1, but not element 0. So that's the beauty of this function. And because we have like material slots index here from 0 to, for instance, 8, the indexes for all of our render targets are the same. So when we retrieve section index here like element 1, we will get the proper index of the render target that is used particularly for this material slot. So make this logic and do the same here. Once it's done, we have the proper render target, so we can use it to draw inside our actor's master material. And that's actually it. That's how it works. You can adjust this logic further, but I guess you'll have the idea, and I tried to explain it perfect as I can. So guys, all is left is to say how you can use this technique as the neat trick to work with the skeletal mesh. Think of your mesh, your skeletal mesh, as the construction. It won't work for very organic forms, but you can use this one even for some robotics, some mechanism, or like the skeletal mesh that has some animations, like cars and so on and so forth. So you need to get your model and break it into the parts where the joints are. So if it's the character, if it's the human, like ankles, legs, thighs, chest, shoulders, arms, forearms, head, and so on. So you break it into the pieces, and you can use it as I've made it with my mesh, this one. So each part, like, it's the copy of the skeletal mesh, but it can be break here, 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 and here. And you can use it because it has the same data, it has the same UV. You can use it to apply over the socket on your skeletal mesh and make this one without collision and make it like invisible. So when you try to trace over it, it will return the proper UV, and with these UV coordinates you can use them as the proper coordinates for your brush to draw over the skeletal mesh material. That's how I made the preview of that demo you saw. That's how I made the demo you saw in the beginning of the video. Sorry guys, a little bit tired. And when you provide this static mesh to the socket of your skeletal mesh, it will inherit the proper movement. But that's not the topic of this video. If you want, I can show it in some next videos. So, if you like my videos, please subscribe, leave your feedback, and also, if you want, you can support me via my Patreon channel. See you soon.